how to solve a system of three equations with three variables. On first step, we will write the equations, which are minus x minus 3y minus 5z equals negative 3. Second equation, negative 3x plus 5y plus 4z equals negative 5. And the last equation will be negative 3x plus 2y minus z equals negative 4. On the following step, what we are going to do is to add or subtract two of the equations to eliminate one of the variables. For example, in equation 2 and equation 3. But if you can notice, negative 3 appears in the two equations. What if I multiply the third equation times negative 1? So what you will have is negative 3x plus 5y plus 4z equals negative 5. And then you will have 3x positive minus 2y plus z equals 4. Then it is a positive 4. Then you add up the equations, and as you can notice, you eliminate negative 3 with 3x, and you will have 3y positive plus 5z equals negative 5 plus 4 is negative 1. Then what you are going to do is to make another elimination using a different pair of equations. You can repeat one of the equations you used before, but now you will use the first equation. So for example, you can use the first equation and the second equation, but you should eliminate also the x in this pair of equations. But to eliminate the x, what if we multiply times negative 3 by the first equation? So what you have is negative 3 times negative x is 3x positive. Negative 3 times negative 3y is plus 9y. Negative 3 times 5z is 15z. And negative 3 times negative 3 is positive 9. You copy the second, and now you will have negative 3x plus 5y plus 4z equals negative 5. You add up the two equations, eliminate the x, and you will have 14y plus 19z equals 4. Now, what you should do is to find the values of y and z using any of the other methods with equations 2 by 2. As you can notice, it's a little bit hard to eliminate one of the two variables, but it is not impossible. What we can do is multiply the upper equation times 14 and then multiply the lower equation times negative 3. As you can notice, we are crisscrossing these two values, but one of them should be negative, so we can eliminate the y. What are you going to have? 3 times 14 is 42, y, plus 5 times 14 is 70, z equals negative 14. 3 times negative 3 is negative 42y, plus 19 times negative 3 will be negative 57 z, and 4 times negative 3 is negative 12. Eliminate y, and now you have 70z minus 57z is 13z positive, equals negative 14 minus 12 is negative 26. So z will be negative 26 over 13, which means that z is a 2. Now you have the value of the first variable, which let me know the value of y. We are going to use the first equation of the first set of elimination to find the value of y by substituting or replacing the value of z by at negative 2. 3y plus 5 times negative 2 is negative 1. So 3y minus 10 equals negative 1. 3y equals negative 1 plus 10. 3y will be 9. So y is 3. I will have the second value, which is 3. Now we can replace negative 2 and 3 in any of the original equations and find the value of x. As you can notice in the first equation, the x is only with a negative, so it will be easier to find the value of x. So now you will have negative x minus 3 times 3 minus 5 times negative 2 equals negative 3. So you have negative x minus 9 plus 10 equals negative 3. And now we add up these two values because they are like terms. You have negative x plus 1 equals negative 3. Now negative x is negative 3 minus 1. Negative x is negative 4, so x is 4. And then now you have the 3 required values. To prove that you have the right values, you can substitute these values in any of the original equations and find the answer, and if it is correct, you will have the same answer. So for example, in the last equation, you should substitute the x by a 4, the y for a 3, and the negative c will be negative 2. Now I have here negative 12 plus 6 plus 2, negative 12 plus 8, and the result of negative 12 plus 8 will be negative 4. This is the same value, so the values we find before are right.